In this lecture, we're going to see how we can return by pointer and get data out of our functions. And we're going to see some problems associated with this way of doing things. Here is a simple example of our max return pointer function. And we know this function is going to return a pointer because we have this little star appended to the return type here. And the input is also going to be passing parameters by pointer. So what we really need to pass in here are addresses of variables. Inside you see that we check and see which pointer contains the maximum value by using the dereference operator like you see here. And we're going to be returning whichever pointer contains the maximum. You see that we return A, and A is a pointer here, and we return B, and B is a pointer as you see on top here. This is how we can use pointers to return data from functions. Okay, this is the definition of the function. Let's look at how you would use this. Here we have, again, the same example we had in the last lecture using references. We have two variables, A and B. We are going to print them out. And we're going to call our maximum function here and pass it addresses because we are passing parameters by reference. The return value is going to be stored in our local variable here, which is a pointer to int. So we're going to be storing the pointer to whatever variable contains the maximum in here, and it is going to be this 15 here in A, and we're going to be printing that maximum here through the dereference operator like you see here. After that, I want you to see that you can go through that pointer and modify whatever data is pointed to by this pointer. In this case, we are going through our dereference operator and incrementing the data at the address pointed to by Pmax here. And that's going to be the data in this A variable here. And if we do this and print the data, in A we're going to get a 16, and B we're going to get our 13 here, using the data that we have in A and B. And on top here, we're just going to print out the data A and B. So we're going to print in 15, and we're going to print 13 here. Okay, and down here, we're going to be dereferencing whatever pointer points to the maximum value, and we're going to print 15 here as well. Okay, this is how you can return by pointer and really do things. And if this way of doing things makes sense for your application, be sure to use this to your advantage. Okay, you also have to be careful when returning by pointer because pointers to local variables are bad and they can lead to the crashes that we saw in the last lecture. Here we are trying to simulate the same problems we saw in the last lecture. Our sum function here is going to return by pointer, so we have a star here, and it is going to take in parameters by pointer as you see here. But what we do inside is setting up a local variable and using the data and the parameters and add that up and store the result in our result variable here. And we're going to return the address of this variable because we are returning by pointer. If we want to return a pointer, we should really return an address of this variable. Once we do this, we will be returning a pointer to an address in memory that will be already dead by the time we try to use this pointer. And if we try to use that, we're going to get a crash. We have the same behavior here, but we are passing by a value and returning by pointer here. So A and B are going to be local variables. And if we return the addresses of these variables, they are going to be local variables, and the pointers to local variables are going to lead us to crashes. So we should be really careful about this. Here is a simple example that is going to use these two functions. Sum is going to return a pointer, and it is going to be a bad pointer. If you try to use it, you're going to get a crash. And down here, we're going to compute the maximum by two variables that we pass by value. These are going to be local copies, local to the function here. And if we return addresses to these variables, store them in a pointer and try to use that pointer here, we're going to get a crash. This is really all we have to talk about in this lecture. We're going to head over to Visual Studio Code and actually see this in action. Okay, here we are in our working folder. The current project is returning by pointer. We're going to grab our template files pretty quick. Put them in place, 19.5, returning by pointer. And we're going to open this in Visual Studio Code by dragging and dropping on top of Visual Studio Code here. This is going to open up our project, and we're going to have our main function here. We can play with it. And we're going to clean it up a little bit and close the left pane here. We don't need it. And we are going to put in our first function, which is going to return by pointer. Again, this function is returning by pointer because we have this star here appended to the return type. It is going to be taking parameters by pointer, as you see here. It is going to try and figure out which pointer contains the maximum value. That's why we are using the dereference operator here. And we're going to be returning A if it happens to be the address in memory containing the maximum. If B happens to contain the maximum value, we're also going to return it. And we can go down and play with this function now. We're going to set up two variables, x and y. Let's do that. Int x is going to contain 56, why not? And int y is going to contain 45. Okay, we're going to set up a pointer variable. So we're going to say pmax. Int pointer, we're going to call this pmax, and it is going to contain the return value of this function here. So we're going to say max return pointer, and we're going to pass in the address of A and the address of B. Because this function is taking parameters by pointer, we're going to give it the addresses of these two variables. And we are saying address of A and B. We have address of X and address of Y. Sorry for this. And if we do this, we're going to have whichever pointer containing the largest value to be assigned to pmax here. Okay, so if we go down here and print whatever value is stored in pmax, we're going to say stdcout, and we're going to dereference pmax, and we're going to do that here. We should get a 56 here contained in this x variable here. Let's try and build this and see if this is actually the case. The build is going to be good. We're going to bring up a terminal and we're going to clear and run Rooster. We're going to see max is 56. This is working exactly like we want. And we are returning values from this function using pointers because we are returning by pointer here. This is how we can get this thing to work. But one thing I want you to see is that we can go through our pointer and modify the data that we are pointing to. One way to show this, we need to print x and y before we do any modification. So we're going to say stdcout, we're going to say x and print x here, and we're going to say y and print y here and put in a new line character. After we do this, we're going to go down and go through the pointer and modify whatever value is pointed to by the pointer. So we're going to say plus plus because we want to increment, and we're going to dereference pmax. This is how we do this. And after we do this and we try to print whatever values are pointed to, let's do that. We're going to go down and put those in place, and we're going to say stdcout, and we're going to put in a few separators here. We're going to build and see what we get. So we're going to build with GCC, and the build is good. We can clear and run Rooster. Now you see that. Let's bring this up a little bit. X is 56, Y is 45, Pmax is 56 because it is a pointer to the largest value. But after we increment, we're going to be incrementing whichever variables contains the maximum. So X is going to contain 57 now, and Pmax is going to be pointing to 57. Hopefully you see that we were able to go through this pointer and modify whatever value was pointed to, and that value was stored in this variable here. These are some things you can do when you return by pointer, like we are doing with the max return pointer function here. And again, depending on the design of your application, this may be a good thing or a bad thing. My job is to make you aware of these possibilities here. You're going to be making your decisions as you grow in your career as a C++ developer. For now, we're going to comment this out and show you bad things that could happen if you try to return pointers to local variables. For that, we're going to go down here and put in a function that is going to return a pointer, but it is going to be returning a pointer to a local variable here. This function is going to be taking two parameters, and by pointer, it is going to set up a local variable, and the local variable is going to store the sum of the values stored at addresses that were passed in here. The point is that this result variable is a local variable to the function, and we are returning an address to it. This is going to be bad because if we happen to catch the return value of this function, store it in a pointer, and use that pointer to dereference or do any kinds of crazy things, we're going to get a crash because by the time we try to use that memory location, this function is going to be long dead, and this memory will be wiped out, and we will be using dead memory basically. Let's go down and set up an example to try this out. We're going to grab these two variables here and reuse them. Let's do that. We're going to set up these two variables, x and y, and the function is called sum. So it is going to be summing up x and y. I think we can use it like this. And the sum is going to be stored in this pointer. But if we try to use this pointer, let's say psum, that's what it is. If we try to use this pointer, we're going to be using dead memory and we're going to get a crash. You might have guessed it. If we try to go down and say std_cout, the reference psum, and say stdendl here, for example, and go down and put in a line to really show that our program is going to crash, we're going to say done here. This is what we have been doing all along to show that our crashes are going to cause for the last line here not to run. Now that we have this set up, we can build our program. The build is going to go through, but it is going to say build finished with warnings. And the warning is going to be address of a local variable result returned. And this is what we are doing here. The compiler is warning us that this is really bad, so we better know what we are doing here. We are stubborn like we were in the last lecture, so we're going to ignore the compiler and we're going to run this. And the program is going to crash. The operating system is going to notice this line here and it is going to know this program must be crazy. It is trying to use memory that doesn't belong to it anymore. I am going to kill it and your program is going to crash. So don't use pointers to local variables because they're going to make your life miserable. Let's try and run Rooster again and see it crashing. You see, the operating system is really trying its best here, but it is going to give up and kill the program here. Again, if we go on top here, this is a local variable we set up ourselves. And it is really obvious that it is a local variable because we declared it ourselves in the body of this function here. But sometimes things aren't this obvious. And I am going to show you why. Let's go down and comment this out because I don't want this to be putting out some noise output. And I am going to go on top and put in our other function, which is going to take two parameters by value and return by pointer. When we pass parameters by value, we are going to be using local copies. The compiler is going to set up local copies of these two variables that we pass as arguments here. And notice here we are returning address of A and address of B. And these are addresses of local variables, and this is going to give us the same problem. We can go down and try this out. We're going to grab the three lines here and reuse them. Why not? And we're going to set up x and y as our variables, and the function is saying max input value. Let's copy this, the name of the function, and we're going to put that in place here. And we're not going to pass addresses of x and y because we are passing by value now. We are going to pass them directly like this, but now psum is going to be containing the address of dead memory when this function finishes execution, and we assign the return value to this pointer here. If we try to use psum now, we're going to get a crash. This is what we expect. And it is what we're going to get. Let's do that. We're going to print this. We're going to build with GCC. The build is going to go through. So build finished with warnings. Again, the warning is address of a local variable result returned. The function with result is active now, but we also see the warning address of local variable B returned. And we should have the same thing for local variable A. You see that here. And this is really bad. If we are stubborn again and try to ignore the warnings from the compiler and still run our program, you see that it is going to crash and the last line here is not going to run. This is really all we set out to do in this lecture, showing you how you can return by pointer. If that helps your application, please do that. But be aware that pointers to local variables are really bad and they are going to crash your program. We are going to stop here in this lecture. In the next one, we're going to see a tiny example on how you can return by pointer and target elements from an array from a function. Go ahead and finish up here and meet me there.